Welcome to my YouTube channel. In this video lecture, we are going to solve questions from sample paper number 7, the RK Bali navigation book. So this is the new edition book, the 7th edition. So we will look at all the questions and solve all of them so that we are very well prepared for our exams. Let's start with question 51 now. Aircraft is heading 140 magnetic, very important. 320 degree true from a VOR station where variation is 10 degree east. The bearing selected on OBS which would make VOR ILS deviation indicator show 2 would be what? So first things first, the heading of aircraft is 140 magnetic. It's at a bearing of 320 degree true from a VOR. Okay, so this is 320 degree true. That means bearing or the radial from the VOR is equal to 320 degree true. Now all VOR radials are magnetic. So we must convert this 320 degree true direction into a magnetic one. So apply variation. Variation is 10 degree east. Variation is 10 east. So radial will be 320 minus 10, 310 magnetic. Okay, so the radial on which your aircraft is positioned is equal to 310 degree magnetic because variation east magnetic will be least. Therefore, 320 minus 10 degree 310. So let's draw the diagram. This is your north datum. Let's say this is your VOR station. Okay, radial is 310 magnetic. Heading of aircraft. Now, heading of aircraft is irrelevant to VOR questions, but still we will plot this 140 magnetic. Okay, 140 magnetic. So a little bit like this. So heading is 140 magnetic. Radial 310. The reciprocal of that is radial 130. Now we want to know the indication in OBS that would centralize the CDI needle. Okay, the bearing that is to be selected in the OBS to centralize the needle with a 2 indication. Now there are two possible solutions. Let's say this is your OBS selector. Now since your aircraft is on radial 310, if we enter radial 310 here, we will get a from indication. If aircraft is correctly positioned on the center line of this radial, the CDI needle will also remain in the center. Okay, so 310 from. Second possibility, if we want two indication in the OBS, what we are going to put is radial 130 or bearing 130. So aircraft is on this side of the VOR, to the northwest of VOR on radial 310. Heading. Now the heading of aircraft is irrelevant. The VOR station only takes or gives outputs depending on what inputs you put in the OBS selector. So since aircraft is to the northwest of VOR, you put 310. So that means the VOR equipment interprets that information as you are being on radial 310. And when you are flying a particular radial 310 or whatever radial, you are expected to fly outbound. Now, if you want a 2 indication, you will get a 2 indication when you are flying the same radial 310 inbound. So if you want to fly inbound towards this VOR, the correct OBS setting will be to put 130 in the OBS. When you do that, you will get a 2 indication. And if you are correctly positioned on the center line of this radial flying inbound, the CDI needle will remain in the center. The CDI needle will remain in the center. So the correct answer here is the bearing that should be selected in the OBS that would make it show 2 indication will be this bearing 130 2 indication. Okay, so you will select that option which has this value 130 with a 2 indication. Okay, make sure you convert this bearing 320 degree true into corresponding magnetic one. Okay, so step 1 is this. Step 2 is this one. Next, TCAS 2 Resolution Advisory provides the pilot with specific instructions on how to avoid the conflict with neighboring traffic. By what? So TCAS 2. TCAS 2 is the next version or an advanced version of TCAS 1. In TCAS 2, you get a traffic advisory first, and if that traffic advisory gets, if that situation which warrants the generation of a traffic advisory, that situation gets worsened or deteriorates, you will get next a resolution advisory. Now, all the resolution advisories given by the TCAS are in vertical plane, are restricted to or limited to vertical plane, meaning the commands that will be given to you by the TCAS will be either in the form of a climbing command, a climb, or a descend command. Okay, climb or a descent. Okay, so you won't get any command which involves turning your aircraft to the left, turning your aircraft to the right. So either it's up or down. Okay, so TCAS Resolution Advisory provides pilot with specific instructions on how to avoid the conflict by quickly and steadily turning left or right, that is wrong. Quickly, steadily increase or decreasing ground speed, no. Quickly and steadily descending, climbing, or adjusting vertical speed. Again, vertical speed is nothing but rate of climb or rate of descent. So option C is the right answer. Okay, very important. Do watch my TCAS lectures in which I have solved all the TCAS questions from Keith Williams' instruments book. I have uploaded those videos to my channel, and I have also marked important points from Oxford TCAS chapter. So if you watch that video, you will mark that, you can watch the video and mark the important points from that chapter. Keep revising those important points for your exam. 53. The indications on the RMI are shown below. Which of the following statements is correct? Now this is an RMI indicator. RMI indicator is nothing but radio magnetic indicator. Okay, radiomagnetic indicator. It gives you three pieces of information. The first is magnetic heading. So remember, it's magnetic heading. It's not the true heading, not compass heading. So first, magnetic heading. Second, you can see here two arrows, two pointers. Now the heads of these pointers will give you the information as to the track that you must follow to go towards a station. Now this station can be a VOR, it can be an NDB station. Okay, so I'm going to write here the head of the pointer. Third, again the head of the pointer. So there are two pointers, right? So head of the pointer. So let's say the first pointer, the head of the first pointer will give you QDM towards the VOR station. The head of the second pointer will give you QDM to the NDB station. Now, if the heads point to give QDM information, that is magnetic bearing, to the station, the tails will give you QDR information, the magnetic bearing from the station, meaning the radial you are situated on or the track you are following to go away from that particular station. Okay, so these three pieces of information. Now, looking at this diagram, magnetic heading. Look at the magnetic heading, 12 o'clock position. It is somewhere around 190, a little bit more than 190. So the options here are 192 magnetic, 192 true, 192 magnetic. So like I said, the magnetic heading information, the heading information is in terms of magnetic. So you're going to eliminate option Bravo because it speaks or it talks about true heading, not magnetic heading. Now we are left with Alpha and Charlie, heading 192 magnetic, heading 192 magnetic. Now look at these two needles. Now needle, this white color needle is your VOR needle, and this needle is your NDB ADF needle. Fine. So now the head of this white needle. or the pointer is pointing towards, this is 300, 310, and 315. So QDM of this VOR is pointing towards 315. The QDM of this NDB needle is pointing at 290, a little bit less than 290, so something, so let's say it's 2, not perfectly 290, it's 288, let's say it's 288. Now QDM for VOR is 315. The tail of that same pointer needle will indicate QDR, the radial your aircraft is positioned on. So that is little bit more than 130. So 132, 133 something. So let's write here QDR is 133 or something. And if you just reverse this 315, the reciprocal of 315 is 135. Okay, so something around that, some value around this value. And similarly for uh, NDB station, the QDR is a little bit less than 110. So 108, 109, whatever. So now let's check the options. Option A, VOR radial 132 magnetic. So we wrote 135. So 132, 135 nearby. Over here, VOR radial 312 magnetic. So that is wrong. 312 or 315 that we have written here is the head of this pointer, the top of this needle, and the top of this needle or pointer will point towards the station. The track you must fly to go to the station. Okay, so it radial cannot be. Radial is a thing or a track that takes you away from the station. If you want to go towards the station, we say bearing to the station. If we want to go away from the station, we use the word radial. Okay, so correct answer is option alpha. Charlie is also eliminated. 54. Aircraft is 60 nautical mile inbound from the VOR. The ILS VOR indicator is set to define the center line of an airway. So here is an indicator. Okay, OBS. Next, the aircraft is located on which radial? What is the type of sensing and OBS? So if you look at this diagram or this picture, you will see you are getting a 2 indication. The CDI needle is telling you to fly left. Okay, you are getting a fly left indication, and you are flying inbound 60 nautical mile inbound from the VOR. So let's say this is your VOR station. Okay, this is your VOR station. This is the north datum. Okay, since you are flying inbound with a 2 indication, look at the center. The OBS selection is 245. OBS selection is 245. So what is the reciprocal of 245? So 245 minus 180 is 065. That means draw radial 065. Draw the reciprocal of that, radial 245. Now you are flying inbound towards this VOR. So that means you are flying radial 065 inbound. When you fly radial 065 inbound, you will be actually flying towards or at a heading of 245 that will take you towards this VOR station. And the distance from this VOR station is 60 nautical miles. Distance is 60 nautical miles. Now what, so aircraft, the question has asked us to find out the radial your aircraft is situated on. So aircraft is situated on radial 065 or around that radial. Okay, so that should be the case, right? But now look at the CDI indication. It tells you to fly left. If it tells you to fly left, that means your aircraft has deviated to the right hand side. Okay, so now going inbound, flying inbound, this becomes your left hand side This becomes your left hand side and this becomes your right hand side perspective. Flying inbound, this will be your left hand side, this will be your right hand side. Now, if aircraft flies correctly on the center line of the radial inbound, the CDI needle will remain in the center position. But if it deviates right or left, accordingly the CDI needle will deviate, giving the solution which direction you must turn to come back to your original radial. Now here it's turned towards the left hand side, means it's giving a solution fly left. So the problem is you have deviated to your right hand side. That means your aircraft is not on this radial correctly. It's somewhere to the right hand side of it since you're flying inbound. So somewhere here, let's say. Now what will be the radial passing through this position? It will be somewhat less than 0.65. It can be 0.62, it can be 0.61, whatever. Okay. Now what is that accurate number? Now look at the dots. Your CDI indication is 1.5 dot to the left hand side. It is to the 1/2. CDI is telling you to fly 1.5 dots the left hand side. Now for VOR calculations, 1 dot is equal to 2 degrees. 1 dot equals to 2 degrees. Okay. So 1.5 dots will be equal to 2 into 1.5, that is 3 degrees. So you are on radial 65 minus 3, 0.62. Since it's to the left hand side, going left, directions decrease, right? And so that's it. So you are currently on radial 0.63. The sensing, it's normal. Okay. There is reverse something sensing, there is something called normal sensing. In normal sensing, you will follow the CDI direction. If the CDI tells you to go left, you go left. In reverse sensing, if the CDI tells you to fly left, you do the reverse of it. You fly right hand side. Now, what is this normal sensing, reverse sensing? You will have to watch my videos on VOR that I have made basis chapters in RK Bali, Oxford, Keith Williams. So when you watch those videos, automatically your concept will be strong. Next is, what is the type of sensing and what is the OBS selected? So since you're flying inbound, you will select the opposite radial. So if you are now currently you have selected radial 245. So you are expected to be on radial 0.65. Okay, so any value around 245. So 245, 246. Now over here, what I can make out is it's between 240 and 250. Okay, so that's why I wrote 245. Here it's written 248. That's fine. So the closest option is option Charlie. So you will select that option. Next. Unless otherwise stated on the charts for standard instrument departure, the routes are given with magnetic heading, true course, magnetic course. Now, standard instrument departure charts are meant to facilitate air traffic, to reduce workload, RT communication, right? And these charts are depicted on your this along with approach charts, standard terminal arrivals. And when you fly a standard instrument departure chart, you must notify the ATC about that. And if you don't want to fly a standard instrument departure, you must notify that thing to ATC also. So whenever you fly a standard instrument departure procedure, you are actually flying a track called magnetic track or magnetic course. Okay, so all those charts are depicted in terms of magnetic direction. So option Charlie is the right one. At night, a position has to be reported to ATC controller. Distance, you're 750 nautical miles away from the station. What frequency is to be used? Now during night time we have disappearance of D layer, the delta layer. Okay, let's say this is your earth surface. This is your D layer. This is the E layer. Okay. Now during daytime you have this D layer, E layer, F1, F2 layers. But during nighttime this D layer disappears. You do not have this D layer. All you have is a little bit of or weak E layer and F1 and F2 layers. So what happens? The radio wave that you are sending towards the ionosphere, it passes through the ionosphere for a much larger distance or a height, vertical distance, and the first wave is reached beyond beyond the point where you would receive the same first sky wave during daytime. If you are receiving the first sky wave during daytime at this place, at night time you will receive the same sky wave at much longer distance, somewhere here. So any aircraft which is able to successfully receive this first sky wave at this position will not be able to receive the same sky wave, the first sky wave, when it's night time. The position is still the same because now at night time the first sky wave reaches beyond the aircraft. Okay, so now practically aircraft will be falling in dead space during night time. So what we do is, because of this disappearance of D layer, we reduce or decrease the frequency values that we are using. So at daytime, if a frequency value is let's say 100 hertz, at night time we will use a lesser frequency tone, let's say 80 hertz, 60, 70 hertz, something like that. So always remember, medium frequency and high frequencies are used for nighttime operations. VHF, again, it's a space wave. It will go through the ionosphere and go out into the space. So therefore, Bravo is eliminated. Now, medium frequency, high frequency are, so 30 to 3 megahertz, 3 megahertz to 30 megahertz. So these are the two bands for medium frequency and high frequency. Okay. So the only option that fits this band will be 5649 kilohertz. 5649 kilohertz, which is a high frequency. Okay. So you will select this frequency. Aircraft flying an ILS is receiving an excess of 90 Hz amplitude modulation. What will be the fly indications on the CDI? Okay, now this ILS instrument gives you fly left, fly right indications. Along with that, it will also give you fly up, fly down indications. Now let's focus on the localizer. When we are talking about localizer, the 90 Hz amplitude modulated signal will be to the left of the center line. 150 Hz signal will be to the right side of the center line, extended center line. So when you are flying correctly on the center line of this runway, okay, when you are flying correctly on the center line of this runway, the OBS selector or the instrument, the CDI instrument, will have the localizer needle right in the center, right in the center. Your aircraft deviates and flies to the left hand side. Instead of flying the center line, okay, correctly, it deviates to the left hand side, left of the extended runway center line. What will happen? The aircraft instrument will receive more of 90 hertz signal and less of 150 hertz signal. So the balance which was existing before when you were flying correctly on the center line, extended center line, that balance will break. It will get or receive more 90 hertz signal and less 150 hertz signal. So what will be the reaction that you will see on the CDI indicator? The CDI indicator is designed to give us a solution, an answer, a reply to whatever problem we are facing. So if we are flying to the left hand side of the center line, our job will be correct that trend and come back to our center line. So our correct action course of action will be to fly right hand side, and then fly this center line straight ahead. Okay. So the CDI indication in this case will, what will it do? It will tell you to fly right hand side. So it will move somewhere here to the right hand side like this. Okay. So you will have to follow that CDI command. Now let's go to glide slope. Now when we are talking about glide slope, we have 90 hertz signal on top of 150 hertz amplitude modulated signal. So again, when you're flying correctly, when you're flying the 3-degree glide slope, the standard 3-degree glide slope correctly, what will happen? The glide slope needle, okay, let's will remain established on the center line like this, horizontal. It will be horizontally established. But the moment your aircraft deviates from the 3-degree glide slope, if it goes up, it goes down, this horizontal needle or pointer will also deflect up or down accordingly. So the job of this needle is to give you a solution. Now, if you deviate above the glide slope, this needle will go below the center line. So this needle will come somewhere down here like this, asking you to fly down. Okay, because that's where the glide slope will be. Now, in this case, you are receiving more of 90 hertz modulation. So 90 hertz modulation will be received when your aircraft deviates above the glide slope. So aircraft is somewhere here. So the solution will be to fly down. Okay, you will have to fly down, descend in order to establish this glide slope and then follow this glide slope down to the runway. Okay, so the CDI needle, this glide slope needle, what will happen to that? It will show a downward trend asking you to fly a few dots down. Okay, so the final result will look something like this. Okay, in words, it will be fly right hand side, the localizer command, and fly down. So you will select this two, an option which has these two commands, fly right and fly down. Okay, 58. A multi-engine aircraft is on IFR flight. Given the following data and assuming fuel consumption remains unchanged, which of the following statements is correct? Trip fuel is 65 US gallon. Contingency fuel is 5% of trip fuel. So 5% of trip, that is 5% of 65. So 5 into 65 divided by 100. So 5 into 65 divided by 100 is 3.25 US gallon. Alternate fuel, including final reserve fuel, is 17 US gallons. Usable fuel at the time of departure is 93 US gallon. At point halfway to destination, fuel consumed is 40 US gallon. So this is the data given to us. Now option alpha states at destination reserves remain intact. That means whatever reserves that you are carrying, 17 US gallon, nothing happens to it. It remains fixed. We are not using those reserve quantity. Remaining fuel is insufficient to reach destination. Remaining fuel is insufficient to reach to destination with reserves intact. Okay, so let's draw the diagram. Here we are on the runway. This is a profile and this is a destination. Okay, so at the time of departure we have 93 US gallon. Midway we have consumed 40 US gallon. Halfway to destination we have consumed 40 US gallon. So remaining fuel is equal to 93 minus 40, that is equal to 53 US gallon. Okay, 53 US gallon. Now trip fuel is 65 US gallon. Total trip fuel is 65 US gallon. Now this usable fuel of 93 US gallon is made up of trip fuel, contingency fuel, reserves fuel. Okay, so let's check. So when you add all these values, 65 plus 3.25 plus alternate reserves 17, you get 65 plus 17 plus 3.25, 85.25. Okay, this is the fuel addition of trip fuel, contingency fuel and reserve fuel. And what is the fuel that you have? You have 93 US gallon. So you are carrying an extra fuel that you are carrying is 93 minus 85.25 is 7.75. You are carrying an extra 7.75 US gallon. Now when you are 50, when you have traveled 50% of the distance, you have consumed 40 US gallon, you are left with another 53 US gallon. Okay, you are left with 53 US gallon. Now this 53 US gallon, whether it's sufficient to reach your destination or not. Now when you consumed another 40 US gallon, so if you take 40 US gallon for halfway distance, remaining halfway distance you will also require 40 US gallon. So the remaining fuel will be at your destination, remaining fuel will be how much? 53 minus 40, that is 13 US gallon. 13 US gallon. Now this 13 US gallon, now let's check whether this 13 US gallon includes reserves or not. Now trip fuel was 65, but how much you will have consumed by the end of your trip? 40 plus another 40, that is 80. Actual trip fuel, actual trip fuel consumed is 80 US gallon. Okay, so which is 80 minus 65, that is 15 gallons more. So you have consumed 15 US gallons more. So you must make some provision for this extra 15 US gallon fuel. So you will take that extra 15 US gallon fuel from reserves, a little bit from reserves, a little bit from contingency. So from contingency you can take maximum 3. So remaining 12 you will have to take from the alternate reserve category, that is 7, it has 17. So out of that 17 you have consumed 12 from there. So that is how you make this provision for another 40 US gallon fuel. So that means the correct answer here will be at destination reserves remain intact. No, we have reserve remains intact. That means reserves are untouched. But the reality is we are forced to use some of the reserve fuel in order to reach our destination. Right? So option A is wrong. Remaining fuel is insufficient to reach destination. So what is the remaining fuel required to reach your destination? Remaining fuel that we have is 53 US gallon. But do we require entire 53 US gallon fuel to go to our destination or more than that? No. What we require is we require an extra 40 US gallon fuel to reach our destination. First half requires 40. The next half will also require another 40 gallons. So that means we have sufficient fuel. We have 53. Out of that 53, we need extra 40 US gallons. Okay, so remaining fuel is insufficient. That is wrong. So remaining fuel is insufficient to reach destination with reserves intact. So option Charlie is right. This remaining fuel will be insufficient if we do not consume the reserve category fuel. if we don't take any help from the reserve category fuel, which is 17 US gallon, and contingency category. If we don't touch these two types of fuel and we completely depend on trip fuel. So what will be the trip fuel remaining after this 50% trip? The trip fuel remaining will be, the total trip fuel is 65 US gallon. Out of that 65, we will consume 40 in the first half. So we will be left with 15 US gallon. Correct? We will be left with uh, 15 US gallon. So this 15 US gallon will be insufficient to go to destination. We require another 25 US gallon fuel, right, to go to our destination. And that extra 15, another 25 US gallon fuel. So that extra fuel we will have to take from some fuel we will have to be take from reserve, and all the fuel from contingency. Okay, so option Charlie is the right answer. Remaining fuel is insufficient. That means the remaining trip fuel will be insufficient to go to destination. So we will have to take some help or extract some fuel from that is meant for reserve category, some fuel for contingency, and definitely pilot has carried extra fuel. Apart from this contingency and reserve, pilot has carried extra 7 gallons of fuel. Okay, so that this has all this makes our flight safe and we reach our destination safely. Next, what is the advantage of a remote indicating compass over a direct reading magnetic compass? So answer is Charlie. It senses the Earth's magnetic field instead of seeking it. Okay, Alpha and Bravo are the disadvantages. Okay, it's not lighter, it's heavier. It's connected to electricity. So yes, it's connected to electricity, but this very thing makes it more vulnerable. If you lose electric power, again this remote indicating magnetic compass will suffer. So Charlie is the best answer. Next, aircraft is on a heading of 340 magnetic, ADF reading 190. What will be the indication on RMI? So RMI. So RMI gives you three pieces of information: magnetic heading, QDM to the station, QDM to VOR, and QDM to NDV station. So here the magnetic heading is 340. So 340 will be on the top. Next, ADF is 190. So here ADF stands for relative bearing. We all know that QDM to the station equals to relative bearing plus magnetic heading. So 190 plus 340 is equal to 530 minus 360 is 170. That means QDM to the station is 17 170. Okay, so 170 will be somewhere here. Reciprocal of 170 will be 350. So QDM is 170 and QDR will be 350. So the needle will be pointing somewhat like this. The head of the needle, which always points towards QDM or track to the station, will point 170, and the tail will be 350. So correct answer will be pointer reads 170 and tail which reads QDR or track away from the station will read 350. So yes, that's it. This concludes our video lecture. I hope you have understood all the 10 questions that I have solved in this video lecture. If you have any doubts or questions, let me know in the comment box. In my next video lecture, I will solve the next remaining questions. So don't miss that video lecture. I request you all to subscribe to this channel if you haven't yet. Share this video with your friends and hit the like button if you